All right, we're going to solve this by factoring. So first thing is we haven't factored anything with a power of 4. So basically the process for anything that's above power of 3 is really similar, but when we start finding our roots, instead of just finding 1, it's good to keep going and kind of find 2, and then you got your first couple steps done. So I'm going to start, of course, by listing the possible factors. So possible factors here are going to be the factors of 6, which are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. But then, because the leading coefficient is 3, we also want to divide all those by 3. So it's going to be plus or minus a third and plus or minus 2/3. I'm not going to go 3 divided by 3 because that's just 1. And I'm not going to go 6 divided by 3 because that's 2. We've already done plus or minus 1 and plus or minus 2. So the goal is always to get it down to a quadratic. So I want to get it to x squared because that's where we know how to factor things. So once we get it down to x squared, we're good. But here, because it's x to the fourth, then I know I got to get 2 binomial factors out to get it to a quadratic. I got to divide that by x twice. So that means I want 2 binomial factors. So I'm going to test 1 first. Subbing 1 in, I get f of 1 equals 0. So I know x of x minus 1 is a factor. And then you can keep subbing values in until you find another one, because it's just useful to know. But usually I just start with the first one and don't really show that I found another one until later on. All right, now I am going to divide 3x to the fourth minus 5x cubed minus 17x squared plus 13x plus 6 by x minus 1 using synthetic division. So I'm going to put the 1 outside, set up my little chart, and put 3, negative 5, negative 17, 13, and 6 across the top. And now the 3 just falls through. 1 times 3 is 3, negative 5 and 3 is negative 2. 1 times negative 2 is negative 2. Negative 17, negative 2 is negative 19. 1 times negative 19 is negative 19. 13 plus negative 19 is negative 6. 1 times negative 6 is negative 6. 6 times negative 6 is 0. And we got 0. That's always my check in case there happened to be a mistake anywhere. So now we know that 3x to the fourth minus 5x cubed minus 17x squared plus 13x plus 6 equals x minus 1 times 3x cubed minus 2x squared minus 19x minus 6. And now we just got to break down that cubic at the end. If you want to, you can basically start again and just act like you're factoring the cubic. So we could go, okay, possible factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, divide them all by 3 again, we get the exact same values. So up above, if you just kept going, which is what I did, and subbing values in, eventually you just find a second 0 and remember till now. So what I remember is that negative 2 worked, so I know f of negative 2 equals 0, so x plus 2 is our next factor. And now we're going to divide x plus 2 out of the cubic though, not out of the original, but out of the quotient when we divided by x minus 1. So negative 2 goes outside, 3, negative 2, negative 19, and negative 6 go across the top. I'm just going to drop that 3 through. 3 times negative 2 is negative 6, negative 8, negative 2 times negative 8 is 16, so I get negative 3, positive 6, and I get a 0. So that's a mistake. That should have been a positive 6. Ooh, I did fix it this time. So then that 0 is the check again. So that tells me that this actually was a factor. If that isn't a 0 there, then a mistake has been made. And now we can write this out. So I know 3x to the fourth minus 5x cubed minus 17x squared plus 13x plus 6 equals x minus 1 times x plus 2 times 3x squared minus 8x minus 3. So that is the quadratic that we now have to factor. So to factor that, because there is a coefficient of 3 attached to x squared, we're going to have to use a different kind of AM method is what I'm going to show you. If you have another way of factoring, that's great, but I'm just going to show you decomposition as a method to factor 3x squared minus 8x minus 3. All right, first step for decomposition is you always multiply your leading coefficient by the constant. So it's 3 times negative 3 is negative 9. And then you're trying to find two numbers that multiply to that product and add to the middle number. So what are two numbers that multiply to negative 9 and add to negative 8? Which is negative 9 and positive 1. Negative 9 times 1 is negative 9. Negative 9 plus 1 is negative 8. So what we do now is we break that middle negative 8x into those two numbers. So this becomes 3x squared minus 9x plus x minus 3. So that negative 9x plus x are like terms, and if you combine them, it gets back to negative 8x. That's kind of what's nice about decomposition, is you can see what exactly is happening. So the next step is out of the first two terms, the 3x squared and the minus 9x, I want to factor out the GCF, which the GCF of those two is 3x. So factoring it out, I get 3x times x minus 3 plus, what's the GCF of x and 3? Well, there is no greatest common factor. It's just a 1 is the only thing we can pull out of both of those, but I'm still going to pull it out. So I'm going to go plus 1 and then in brackets x minus 3. Now, x minus 3 is a common binomial factor. So I'm going to factor that out in front, and what I'm left with is whatever isn't an x minus 3, which is 3x plus 1 in the second set of brackets. Now we got everything. So this is factored. So 3x to the fourth minus 5x cubed minus 17x squared plus 13x plus 6 equals x minus 1, x plus 2, and then the two factors we just found, x minus 3 and 3x plus 1. So that is the fourth degree polynomial completely factored. But this question was asking us to solve, so now we got to say what the zeros were, which they're always the opposite. So it's going to be positive 1, negative 2, and positive 3. And then that 3x plus 1, we just have to remember it's always the opposite of the plus 1 is negative 1, and then put it over whatever's attached to x. So it's got a 0 of negative a third. And this is done.